So this is the mail that we have received, which is directly related to the previous mail and also directly related to this main project. So what we can do is like we can just read this mail. We will first see from where do we get this mail, because see, once you are working for a client, working for a stakeholder in the company, you always have to see like who have sent this mail. Okay, this is the first thing. Who have actually sent this mail? Is it like from directly from your manager, or from the stakeholder managers, or from the stakeholder manager's manager? Because why I am saying this, so that you can know about the priority, in what priority you should complete this, or in what priority you should reply them back. That's it. Okay, it is always related to the priority basis. Okay, let me just correct it. I hope it is okay. Yeah, it is always related to the priority basis, correct? So that is the reason why I am saying this. Always check from where do you have received the mail. Once you check it, just carry on with it. That's it, nothing else. So we have seen like this is directly from the data science team. There is no particular point of contact from any other source or any other manager or stakeholder. Like if you have checked out my previous work, you would have seen like the BI team have directly told us to do this or do some work, additional work, and all those stuffs like that. Okay, sometimes what happened, the directors team, they connect you for some data work. Sometimes the finance team connect you for some data work, like for the Power BI project, if you have seen, right? Correct. Right now what we will do, we will read each and every point from the mail, and then we will directly move to our this screen. I mean to say this SQL, I mean Python environment, not SQL environment here. And here also we have one more thing that is related to the whiteboard and related to the project. We will just tell me what happened. We will just understand the topic point to point with the help of the whiteboard, right? Wherever required, I will use whiteboard and explain it to you. Okay, so in that meantime, let us go to the mail and let's see what it is all about. So in the mail, what they have told, they have directly told us that I hope this email finds you well. I'm reaching out to request development of stock volatility prediction. Like if you remember, let me show you here in this Python environment related to the volatility work. We have already done some volatility. Okay, see here, like volatility 30 days. We have already, like if you have not seen the part 1, I would request you to first go and check out the part 1, so that you would have an idea like what we are going through, what we are like, what kind of requirement are we taking care of. That's what it is all about. So the thing is, for volatility 30 days, we have already done some findings of the requirement. So we will take this data and continue with finding others requirement, right? That's the thing. So let us move to the empty cell. See, this is okay. We will do these things as well. So what we will do here, let us go to the mail. In this, they have given some requirements like 1 2 3 4 5 6 7 8 9. So there are total 9 requirements available here. So we will go one by one, right? So this is the first requirement. It is like they have asked for data normalization, where they want to implement the min max scaling to normalize volatility values to a constant range, right? Before that, we have to do some work. We have to give some variable, I mean we have to create some variables, we have to store some data, and then we will go through it. Okay, we will explain step by step, so no need to worry about. Okay, so here what we have, before moving to the normalization part, first of all we will load the data, right? Like I've told you, we will load the volatility 30 data, like 30 days volatility. For that, let me give this. I first of all, let me give the requirement 1. Okay, In hash, if you like click hash now, it is like it will become a comment in Python, and if you give dash, it will become comment in SQL. That's it. So let's give vol data. Oops. ठीक है, this is what variable I am giving right now. You can give any variable, is just a name, so no worries for that. In this I will give volatility 30. ठीक है, वो oh sorry, volatility 30. Like I've told you, the data that we have actually fetched in the first part. So volatility 30 we have took. Right now we will write the stock name and we will just do some dropping of NA. Right, NA matlab not applicable, not available, sorry, not available, NA. We will first do a drop NA. But here there is a twist. Here I will add like this: stock name dot drop NA. ठीक है. Right now you might be having a question like why double bracket? Earlier I have used single bracket. Like why are we using double bracket here? So before that, let us come step by step so that we can get an easy understanding. So we will first load and clean the data. This is a kind of data cleaning where we are using drop NA, right? So volatility 30, if you check it out here, volatility 30 is a simple data frame name that already exists. You have seen that it contains volatility data for stocks of 30 days, right? 30 days. ठीक है, simple. We are taking 10 stocks, but 30 days is taken out here. ठीक है, that's why. Here you will see one thing. I have written stock name with a double bracket, right? Why I have given double bracket is like I have given double bracket because double bracket select one column in Python environment and double bracket returns a data frame. Single bracket, why not single bracket? Obviously single bracket returns a series, that's why. Let me just show you here something. Stock name. ठीक है, let me show you here. See, we have already have this stock name and all kind of thing. Stock name we have. ठीक है, like in case if you are thinking like where do we got stock name and all, and drop NA, we are doing what we are doing, we are just dropping NA, that's it. ठीक है, let's execute it. Done. No error. Did we get any error? No error. ठीक है. Right now we will go to the first requirement like normalizing, and also one more thing, one more additional thing. You can write a note. By double bracket, as I've told you, double bracket returns a data frame. And why we need a data frame? Why not a series with a single bracket? We need a data frame because for ML or machine learning, data frame structure are given first priority, or I would say this is where we all do the work. That's why, that is the only reason. So you can write a note for this. And also if you are writing a note, let me just continue with it for drop NA. Drop NA, like in, let me tell you one thing, there are some missing data like NA and NA. Like NA, N is not a number if you remember. So drop NA, what it does, drop NA removes any row with missing values. ठीक है, that's it. Just for note taking I am told about drop NA. So right now what we will do, we will normalize the data. ठीक है, we will normalize the data. I will give min max scalar. ठीक है, simple as it is. I will write here 2. ठीक, I will write scalar. I will write here scalar, then I will give min max. Oh, sorry for the spelling mistake. Then I will give here min max scalar. If you have seen my first video, min max scalar is already there in this. Let me show you out here. This min max scalar is already there. ठीक है, the thing is that where is it? हाँ चलो ठीक है, min max scalar I will do. Right now, first line, let us understand what it is. It is like creating a scalar object. ठीक है, it's like a tool that will learn the min max value from our data. That's it. Right now I will write a kind of fit transformation kind of thing. Let me write it so that you will understand. I will write wall. Let me give a name so that it is easy for you to understand, like scalar dot fit, sorry, fit transform, and in this I will give wall data. You know where wall data came from? Okay, that's it. Right now let's understand what is wall scale. Obviously wall scale is a variable name. So what is this scalar, fit, transform, all those stuffs? Let us understand this. In this line there are two steps. If you see here, there are two steps. First is fit, then transformation. Although we have written fit transformation with an underscore, but fit transformation, there are two steps that is actually going on behind the scenes. First step is fit, right? First step is fit. In this fit, what is happening? In this fit, what is happening? It learns the minimum and maximum value from volume data. Volatility, sorry, not volume, volatility data, VOL data. That is on the first place, you can see. So min value, minimum volatility will be around 0.01 and maximum volatility will be around 0.08, and that will be stored in a scalar object, the variable. Second thing is the transform. Okay, what is transform? Like we have used fit and transform. Like what is transform? So transform is about applying a scaling formula to each value. Okay, what is the actual formula there in the fit transform in the back end? It is about x minus min divided by max minus min. Let me write it here. It is all about transform, right? Let me write it here. Transform. It is all about what was that? It is all, I also forgot, x minus min divided by max minus min. X minus min divided by max minus min. If you want, you can take a note of it. No worries for that. Okay. So what is this? What is this all about? Let me give an example, simple example. Okay. Let me show you a data set example. I am saying not data set 0.01. Let us take some three data 0.045 and let me take 0.08. Okay. These are the things. Okay. These are the data. I am writing it here. 1, 2, 3. So right now we will use the formula. Okay, we will use this formula. That's just I am giving an example and I hope it is visible. Yeah, it's visible. So the thing is, what I will do for transforming 0.01. Okay, so we will take x equal to 0.01 and we will implement in the formula. So 0.01 minus min. Okay, here what is the min in this three data? 0.01. Let me write it here. Min 0.01. Max is what? What's the max all about? 0.08. Okay. Min max. Okay. That's the thing. Divided by max minus min. Max minus min is how much? 0.08 minus 0.01. Okay, it's like that, simple. And what will be the answer? Obviously 0, thanks to this. Not thanks to this, but yeah, thanks to this. Same thing will happen for this 0.045. Okay, same thing will happen for this. So 0.045 minus 0.01 divided by 0.08 minus 0.01. ठीक है. What will be the answer in this? कितना होगा? 0.07 It will be around, I think it will be minus 0. Now 554. I think it will be sorry for the wrong answer, but I think it will be 0.5. Okay, like that. So this thing, how things goes on. Okay, this is just an example I am showing. How does fit transform work? Okay, how does fit and transform work? Because I just want to show you like how things actually go behind the scenes. Okay, like that. So what it will happen, it will just give you a normalized data, like the first data is 0. Okay, second data suppose it came 0.5, like that. Suppose for the 3 data, what data it will come? 0, 0.5. Suppose next data comes 0.2. Example I'm saying, just an example, take it. Okay, for the 3 data, for the 3x, like 0.01, 0.045 and 0.08. Okay, and x matlab this number, not x. Okay, so the values, like if we check the values, it is about what? It is about what? If we check the values, it is directly the values are between 0 and 1. If you check this, what it is all about? The values are between 0 and 1. If you write a scale, like if you have seen the graph 0, 1, 2, so it is like 0 is there, 0.5, 0.2, like that. It is like that, simple as it is like that, simple. So what it will do, why are we doing this? Because the neural network work better with normalized data. Why it works better with normalized data? Because there is no gradient explosion, there is no faster convergence, and also there is better learning in this. And we keep the scalar object later when the model, suppose if the model predicts 0.5 for some reason, we can reverse it to 0.045, and this is how we convert prediction back to real volatility numbers, right? We will do it at the end, no worries for that. Okay, right now we have done with this normalization part. Let me go here and let me just execute it. No error, thank god. Let me just go with the next requirement. Okay, what's the next requirement all about? Let me just close it. I mean, not close it. We will just do a sequence creation. Okay, what we will do? We will do some sequence creation here. Okay, simple as it is. We will do some sequence creation here, right? So sequence creation and anything. Okay, what it is all about, let me just copy and paste it. Okay, let me just copy and paste it so that for explanation it will be easy for you to understand. Okay, where is it? So sequence creation, what they are asking for, they want to generate a time series sequence of 60 days windows to serve as model input with proper stride optimization. Let's understand this line of code step by step and let's write it here. Okay, I have written number 3. Number 3 for what? Sequence wala part. Just understand it. Okay, sequence wala part. This was scalar, this was sequence. Okay, so what it is all about, we will create a sequence. So let's write the code first, then I will explain you step by step. Okay, let's write the code first. Let me just give what we say, variable name, and I will give a flattened scale like this. What was the thing? Wall scaled. I will just take it here so that it is easy for you to understand what I am taking from. Flattened. FL no ED नहीं है शायद, flatten है, what I remember, flatten. Okay, if error comes we will take care of it. So it is flattened. ठीक है, wall flatten, a wall scale dot flatten. So what it is all about, we are creating a sequence for RNN, right? So for that we have to first flat the data. Current shape of the data, if you see, it is always in rows and column. Okay, if you go and check the data frame, it is always into rows and column, right? And when you flat the data, what it is actually mean, flat the data means we are actually doing a 1D array, okay, one dimension. That is why we are doing this, because our special sequence creation tool works on 1D array, that's a one dimension. And you can think of it like we had a vertical list of number and we have a horizontal line of number. So same data, same shape, that's why we have to reshape it for the sequence on all, when we will do it for the next part, no worries for that. We will do the reshaping part. If you have seen the mail, next part is all about reshaping. Right now we will give one more requirement for the length of the volume, okay, length of the volume. So for that, let me write this. No, let me give the variable name. Let me give num samples, ठीक है, it will be easy for uh, you to understand like what kind of variables I am giving. Length, in this I will give the volume flat. Now here we will do some calculation part, minus 60, ठीक है. So what it is all about, why we are doing this and what it is all about. So it will calculate how many sequence we can create. Suppose we have a data of example 980 points. So 980 minus 60 is what? 920, right? That is what the formula all about. Okay? This is the thing. So we are creating a windows for this. Suppose let us go to the whiteboard. In this, what we are doing, we are creating window here. Okay? Suppose window 1 is all about window. What actually window 1 is doing? Window 1 is all about day 0 to 59. How many days? 60 days. ठीक है. Now let's take this window 2. Window 2 is all about what? How many days here? 60 days. ठीक है. Right now you understood what I am trying to say. Series, window series will happen. ठीक है. Now here what will happen? Here what will happen? Same, 60 days. We are increasing plus here, that's it, nothing else. ठीक है. So in this, when we will do this, right, what we have already done, 980 minus 60. 980 minus 60 is what? All about 920. So window 920 will have around 920 minus 979, which will be a 60 values window. So each window need 60 consecutive values. So last valid start position is like indexing 920, and we can get 920 minus 979, which is the 60 values and all. So we can create total of 920 different 60 days window. We have to create windows for that. That's what we are doing. We are creating, see, you see the length, I have given length. Length matlab it will create a window. It will take the length of the 1D array and keep it for the sample. And why I have written this num sample? This is for sample size of 60 days. That's it. Simple. Right now we will write for the X volume and Y volume, and then we will go with the flow. Let's move to the whiteboard, right? So we have X volume. ठीक है. We will write X volume here. Let me just control. Oops, sorry. Oops. Let's see what we have. x train y train we have, ठीक है. So we have to take care of x volume, just checking like have we find any x volume or not earlier. That's why I'm just checking about it. That's the thing. So x volume, ठीक है. In x volume what we will write, we will write some quotes and queries here. We will explain, I will explain it, no worries for that. And here we will be using numpy, ठीक है. So np dot, we will use L, don't worry about it, we will explain each and everything. Right, tricks, sprite tricks as strided, and then we will write some queries inside it, ठीक है. First of all let me write the query inside, then I will explain you step by step what it is all about, ठीक है. No worries for that. In this I will take, let's remove this volume flat, then I will take shape equal to, I will take num sample, I will take here num samples, then I will take 60. After that we will take this strides, and in strides what we will do, we will take this flat dot volume strides, then flat also we will take like x and y axis, right. Just copy and paste it, why to write it, just copy and paste it, why to write it, okay. And we will close the bracket here, take this for the third part. Okay, now let's move to the explanation part, like why we did this and why do we need to do it. Simple. So in this you see, this is the most important line, take care of it. We are creating sequence for this. What it does, it will create a 2D view, remember 2D view of 1D array using memory pointers, ठीक है. This, and here it is not copying any data, it is just creating a view. So for the parameters, what things we have used, we have used vol flat. And what is vol flat, we have already given vol flat for a flattened part. If you check this out, ठीक है. What it does, the 1D array to work with, simple. Second requirement what we have given, or second parameter we have given a shape what I have told, given 60. Why 60? We have took 60 earlier, and for the 920 windows 60 values each. If you check out for the window how I have done 0 to 59, 1 to 60, like that. Third parameter we have took strides, where we have taken care of the memory strides information. So volume flat, which I have already used, dot strides, what it does is like the size of one element in byte, okay. So why I have written this 2 times, now you might have understood, like I have told, like it is for both row and column stride, so same value will be there, and this creates overlapping windows, okay. That's it, nothing else. That's the thing. Right now we will have to create for the y volume as well, okay. y volume, ठीक है. In y volume we will just keep a volume flat of 60, volume flat 60. And I know most of you might have understand till here we are using slice here, ठीक है. So we are creating target values that we want to predict, ठीक है. That's it. And here what we have used slice. If you remember this slice wala part, what it is all about, ठीक है. It is like start with index 60, go to the end. That is what we are doing. Start with index 60, go to the end, because after this I have not written anything. So it will go till end. But starting point I have given a number. I have given a, it's not a normal number, it's a index number. It's a index. So it will start with index 60, go till the end. That's it. Okay? That's the thing. So we have done till here. Let's execute it. Okay, no errors, no worries. Now let's move to the fourth requirement, what it is all about. Let's move to the mail actually. Okay, for the fourth here, but third in the mail. Okay, third in the mail, fourth in our Python environment, right? So what we will do, we will do data reshaping right now. What is data reshaping? Like, I mean to say, what they have asked for data reshaping, not what is data reshaping. What they have actually asked for data reshaping. They have asked to format sequences into 3D arrays, जैसे कि samples into time steps into features, and it will create a suitability for deep learning. ठीक है, for deep learning. What it is all about, let me just copy it here, and this paste it, right? And please stay with me till the end. The thing is ki I know it is bit boring. That is the reason why data scientists earn a lot, because boring things actually give lot of money, to be honest, right? Trust me, things which are boring, things which are not liked by other, things which are not studied by other, pay a lot. That's it. That's the thing. That's one. So please stay with me. Okay? I know it is boring, because I am also feeling really boring with this topic, but still anyhow we have to do it, right? Because anyhow we have to do it, because it's a data science project, and still there is no excuse for that. Sorry, I'm stammering right now. So right now what we will do, we will reshape the neural network. Okay, for this we have to write a command, right? xvol, for that is for x volatility. Okay, in case I might have said volume, please sorry for that. In case by flow of like words flow I might have told volume, it's actually volatility. So here what we will be doing, we will do reshape of the values. ठीक है, reshape of what values? X values that we have actually find out in the third requirement, x wall. ठीक है, simple as it is. We will reshape it. How we will reshape it? Simple. Let me write the query, I mean command here, then we will go with the flow. x wall dot reshape. ठीक है, reshape is a function. तो x, in this we will also give the shape x wall dot shape. ठीक है, in this shape we will give two times for rows and columns. ठीक है, 0 comma, let me just execute it, comma this. Here we will give 1. Why we will give 1? I will explain it to you right now. So what we are doing here, simple, we are reshaping the data for RNN requirement, neural network requirement. And what was the current shape in the previous part, third requirement? It was like 920 comma 60. So 920 samples, 60 timestamp each. ठीक है, 0 to 59, 1 to 60 days, like that. And here the one that we are giving is for one feature. And why we are using this? Because for the RNN, okay, let me write what is RNN first thing first. I am always saying RNN, and okay, so here features is there, time step samples. ठीक है, let me give it. ठीक है, I hope right now you got it. Why I have given like this. Okay, we will explain this, but still, first write what is RNN. So those who know about it, please write in the comment section. Those who don't know, no worries. We will write it here, not in comment section, but in the whiteboard. It is recurrent neural networks. Okay? Recurrent. Sorry for I'm really bad at spelling. I don't know why. Neural networks. ठीक है. RNN is all about recurrent neural networks, and what parameters or what requirements do RNN needs? It needs the batch size, the time steps, and the features. ठीक है. It needs what? Three things: batch size, time step, sorry, features. So it need three things. ठीक है. I hope you got it. What three things do it actually need? Simple as it is. ठीक है. It need three things: batch size 920, time step 60 मतलब days in each sequence, and one for features, just volatility. So okay, right now you might be having a question: why one feature, why not two, why not three, why not some xyz number? We predict one thing, that is volatility. That's why one feature. If predicting volatility and price, two. If using 5 indicators, then 5. So feature right now for this requirement is what? Volatility. In this mail you might have seen, it is related to volatility. This is what we are saying for the feature. And one important note is like for the tensor flow, it requires this exact shape. Without reshape, you will get an error. Tensor flow is a library that I have already imported in the first part of the video, right? That's the thing. We have done the reshape here. So let's go to here and let's pray to God and say, okay, no error. The only fear what I have is like error. Okay, that's the only fear what I have. But still, fear is what? Challenges. And if you clear out the challenges, you are on top of the world. That's it. What I believe. But anyways, this is the third requirement that we have find out. Let's move to the mail. Okay. Third requirement here, fourth requirement in our requirement basis. ठीक. Right now we will have to do train test split. What we have to do, we have to divide data into 80% training, 20% testing sets that we have actually done in the previous requirements. If you have seen like part 1, you might have understood like the training and testing part is all about 80% training and 20% testing. So what they have told, like this sets will while preserving temporal order and no shuffling is required. Okay, so let's take this thing, copy it and just paste it. Okay. Copy it and we have pasted it here. No worries for that, right? We have properly pasted it here. Right now what we have, training and testing part. Okay, simple training and testing part will be done. Let me just okay, now let's move. Where is my I am always saying SQL environment, really sorry for that. So what we will do, we will do the split part. Okay, we will take X train here, we will take X train here, and I will tell each and everything, no worry. We will take X test here, and then we will take Y train, Y test. Oh, sorry. Where did it came from? I will show you here. See, X I have already told. Okay. Now see here. See, X test we have already find out in the first requirement. See, X train, Y train, X test, Y test. We have already found these things here in the first requirement. That's the reason I'm saying if you have not seen the first requirement, first go and check that out so that you can get the track of the project, like where we are heading to, what we are actually doing, because each and everything is connected to this. That's what I'm saying, right? So let's go to the end and close it. Okay, we will be doing this thing here, and we will do equal to train test split. We will do the train test split, and in this train test split what we will do, we will give this x and y volume. Okay, simple. We will give this x and y volume. Okay, I will just copy and paste it here so that it is easy for you to understand. X volume and Y volume here. I will, don't worry about it. I will explain it each and everything step by step, right? No worries for that. And I will take the test size as 0.2 and shuffle as false. ठीक. Why shuffle as false? Because in the mail they have told no reshuffling. That's why. Shuffle as false. ठीक है. So let's understand it right now what it is all about. Train test split, what it is all about. So it take data and split it. Simple. For that we need some parameters. What parameters do we need? We need x volume and y volume. They are the data and target. ठीक है. Test size 0.2. What it is all about? 20% testing, 80% training. 0.2 is what? 20%. 2% जो हम लोग बोलते हैं ना, 20% is what 0.2 all about. 20% testing, 80% training. Shuffle false in the mail they have already told, because also it is critical for time series. That's why they have told for no reshuffling. And in this we will get output in 4 variables. Why 4 variables? You can see here: x train, x test, y train and y test. 4 variables are there. So x train, what it will do? It will do 80% of the sequence for training. X test, what it will do? It will do 20% sequence of the testing. Y train, what it will do? 80% training for the targets of training and 20% target of testing. See, ठीक है, simple as it is. If you go with the maths part, let's go to the white screen. If you go to the maths part, like what it is all about, so it will do 80 and 20%. How many sequences are there? 920 sequences we have made. 920 into 80%. ठीक है, and 920 into 20%. ठीक है, this is what they will do. 8 to the 16, 72, 73. This is what actually they will do. Simple as it is, right? Simple as it is. 8 to 16. I hope my maths is correct. So training will be 736 training and testing will be around 184 testing. Simple as it is. ठीक है, that's the thing. We have done the split here. ठीक. Right now let's go to the mail and let's see what they have actually asked for, right? I think we have to build models and all. ठीक है, we have to build models and all, what I believe. Ah, I've told the right thing because I've actually seen it. That's why. Sorry. So here we have to create a model architecture that is GRU based. So model architecture. So what they have asked here all about, they have asked here to build an architecture of GR. Okay, let me explain something related to GRU. Like, let us at least talk about the full form so that it is easy for you to understand. What is GRU? So, GRU is gated recurrent unit. Let me write it here. What is GRU? Right? Gated recurrent unit. Simple. GRU is what? Gated recurrent unit. Simple. Just an explanation I'm saying because I know you will be like feeling all the way like what is GRU, what is all those stuffs and all. Okay, that's why. So what they have told, let's start from the starting. They've asked for the model architecture to build a GRU based neural network with two GRU layers, 50 units each, and return sequences enabled on the first layer. Okay, so dropout regularization where 20% after each GRU layer to prevent overfitting. So we will be creating layers as well. Okay, no worries, we will create it. So it is like dense output layer for volatility prediction and Adam optimizer with MSE loss function. Okay, so Adam will also be used. Let me just copy here, copy it. I mean to say, let me just copy it and paste it here, right? That's the thing. I hope you can check it out. Okay. That's the thing, right? So right now what we will do, we will create a model architect. So let me just yeah, hashtag 6. So right now we will be building a model. Simple. So for model we will write model, right? Any variable name you can give, no worries for that. And it will be what? It will be sequential model, right? We will be creating a sequential model. So let me just write each and everything sequential. Then I will explain you step by step. ठीक है sequential, then I will write GRU. I will explain each and everything, so just chill, no worries for it. I know you will be feeling like what I am writing and all those stuffs and all, but no worries for it. QUEN sequences, and here in return sequences I will write true. Okay, then input shape 60 will be there. Yeah, simple as it is. Okay, one more comma bracket will be there. Okay. Then simple we will give a dropout. Give a dropout of what? 0.2. We will give a dropout of what? 0.2. Then GRU model, GRU will be 0.2 because they have told for 20%. That's why I hope you are getting it right now what it is all about. Then dropout again for 0.2, and then we will go for dense of 1, right? We will go for dense of 1. Okay. Then I think we should compile the model in a way. Should I compile the model right now? Then we can go, right? Should I compile the model? What do you say? That what I'm thinking. Model compile should be done or not. Okay, let's do the model compilation as well. Let's do it in a normal way. Uh, um, Compile, because we have already seen we have to use the optimizer. Adam will be used. Oh, sorry, I'm writing spelling mistake. That's why it is showing. Adam will be used and loss for MSE. ठीक है. Okay. Let us go point to point, then I will execute it step by step. So in this, what we have, simple. In this, what we have done, we will be creating after the executing a sequential model. So in this sequential model, we are having layers stacked on top of each other. What is layer stack? If you have seen here, they are saying 50 unit each, right? That's the reason I have written 50. ठीक है, simple. 50 unit each, that's why 50, right? Simple as it is. So it will read 60 time step one at a time, and in each time step it will read current volatility. It will remember important info from previous time step. It will update some hidden steps, and it will decide what to forget. But right now you will be having a mind. Earlier I was saying 50 units, why 60 and all. 50 units matlab 50 internal neurons. It is all about neurons, not the timestamp. So more units, which means more capability, and learning complex pattern will be easier for it. So also there is one disadvantage of it, like slower training will be there and more overfitting risk will be here. So 50 is a kind of proven good for more problems. Let me tell you, proven good number, as my friend have told from Amazon. He's a data scientist and he is helping out with me in this project, and he had told me to took 50 layers because of proper execution and proper output. That's why. Also, 50 part, I hope you understood. Right now we will go to return sequences. So what is return sequences and why I have written it true? So return sequences true matlab all the output of 60 time step. What it will do? It will give the output of all the 60 time step. That's why true. What if I have written false? If I have written false, then it will give the output of only final time step. That's why. So we use true because next layer needs all the output. That's the reason, because we are training the model, right? That's the thing. And input shape. Now let's go to input shape. Here we have given 60 comma 1. 60 comma 1, right now you might have understood. 60 is what? Time step. 1 is what? Feature. Feature matlab volatility. 60 time step 1 feature each. Simple as it is. ठीक है. After that, what we have a dropout. So dropout 0.2 is there. We have added dropout for what? Regularization. Why? You see, dropout regularization 20% after each GRU layer to prevent what? Overfitting. Okay? That's why. What dropout actually does, because it's a new thing to you all, that's why. Means in the second part, dropout is like during training, and what it does is like it randomly disables 20% of the neurons, right? And others scale up to compensate for that, and it forces network to learn some robust features. That's why. And that is during training, just remember. And during testing, what happens? All the neurons get active and scaled down by 1 minus 0.2, which is 0.8. Simple, right? So why 0.2? Because 0.1 is 10%. It is like light kind of regularization. What my friend have told, why 0.2? That's why 0.2 is kind of standard. This is what we actually use, and what they also actually use with the Amazon work wala part. 0.3 is like 30% stronger regularization and all those stuffs, and 0.5 is what? These are very strong kind of regularization. So 20% is a kind of good proven work done kind of thing. That's what it is all about. And why it works, like I have told you, it prevents overfitting, and the model learns to not depend on single neuron. That's what I'm saying. That's the thing, right? Right now you can see we have GRU, sorry, GRU 50 with dropout 0.2. ठीक है, in this is the second layer. Earlier you see dropout 0.2 was there, here also dropout 0.2 is there. So this is what, this is like second GRU layer, then dropout again will happen. Okay, so this is second GRU 50. So it processes the output from the first GRU, like I've told you now, it will process the output, it will learn, and it will then use the output for learning the next part of it. That's why. So it processed the output from the first GRU, and first GRU learn the basics temporal pattern. Second GRU learn pattern in a more sophisticated way. So there won't be return sequences. Okay. That's the reason we have used return sequence equal to true. Right? That's the only reason of it. So more sophisticated learning, that's it. And they have also told return sequence, I mean we have, sorry, not they, we have also used return sequence equal to true. So output will be the final time step if we use return sequence equal to false. Return sequence equal to true means all the 60 output will be there. Okay, that's it. I hope you are getting this. If not, you can ask me in the comment section. Now let's move to the dense part. Why this dense part? Dense, what it does, it's kind of, not a kind of, but it is the final output layer. So dense one is what, it is a fully connected layer. So all the 50 inputs connect to one output. And this is what work as a prediction layer, and this is why it is the important layer, because this is the one output that actually give us the prediction layer, that is dense equal to 1. So what will be the flow of it? It will do a multiplication like 50 into 1 matrix like that. Okay. And why we have written 1, you might having a question like why dense equal to 1, why not dense equal to 2, why not 3, like feature I have told feature equal to 1, why not feature 2, 3 and all, because we are using volatility, that's why feature equal to 1. Why we have used 1 unit? Because we predict one thing, volatility. That is it. That is it. That's it. That's why dense equal to 1. If predicting 3 things or 4 things or 5 things, then it will be dense on inside bracket, it will be 3, 4 and 5. That's it. Okay? That's what it is all about. Right now let's move to the model part. So in model we have done some compilation, right? Compilation, we have used optimizer, Adam and all those stuff. So what it is all about? It is like kind of preparing for training, compiling for training or preparing for training. These are the same things. So what actually compile does is like it specify the optimizer like how to update weights, and also specify loss function like what to minimize. Okay. So optimizer, you can see it is like written Adam. So Adam is not about Adam and Eve. There is a full form of it. Let me write it, because earlier I have also asked my friend like is it all about Adam and Eve? No. Adam have a full form of it. If you know the full form, you can write it in the comment section. If not, I am writing it here in the whiteboard. Adam is adaptive moment estimation, right? Adaptive moment estimation. Oh, sorry, ADAM. Okay. This is Adam, right? Adam is what? Adaptive moment estimation. So how the model updates weights during training, and why Adam? So Adam adjusts the learning rate per parameter and it combines the momentum plus RMS prop and also grade to work for RNN, right? And also it is an industrial standard. Right now, like Adam have a full form, MSE also have a full form. Let's write it here. If you know about the full form of MSE, please stop the video and write it in the comment section. If not, I am writing it in the whiteboard. What is MSE? MSE means mean squared error. Mean square error. ठीक है? Simple. MSE means mean squared error, not meme. So what we are trying to minimize, and what is the actual formula of MSE? Actually, there is a formula of MSE. My friend have told me it is like this: average of error square. Average of error square. It is the formula of it. It is actually the formula for it, right? Why MSE? Okay, why MSE? MSE means heavy penalty for large error. Penalty is there. So smooth gradient, and why we are using this? Because it is like creating a smooth gradient for optimization and it is standard for regression. That's why. So error will be there for that. And also once we execute this thing, not this whiteboard, this thing, let's see, do it give a error, or let's see if it creates a good thing. Okay. Mm, mm, mm. Okay. So here they have done a issue, but no worries, no worries. This issue had actually came earlier. That's why I'm saying we have to first right now train the model, then only it will work. So let me first train the model, then let's see if the issue is there or not. Let me first train the model. I know this thing will happen. That's why, but still, let me check once. Let me check once. GRU. Oh. Actually, error is here. I have actually noted in GRU 50. Exit. GRU 50 is there. Still, it's not working. GRU is there. 50 return sequence true. Everything is okay. Input this. Drop out, then GRU. 50 drop out, then 1. Then one, why I have given this comma, I don't know, to be honest. Right now, let's see. Okay, still we are getting an issue. No worries for it. Let me write it here. Step by step. Return sequences true. Okay, one more mistake, optimizer. Still there is a issue. compile optimizer. Hmm. We have to remove this issue and we are removing other issues. Okay. Right now it is okay right now. Matlab still, there was an error here already, GRU 0.2, and I am just removing other things here, like what things I have removed without removing the main error. So these things happens, no worries for it. These things actually happens, like why these things are happening, if you might be thinking. So these things actually happen, you clear all other error and after that you clear out the main error. I don't know why, thanks to my brain, literally thanks to my brain. Okay, anyways, now let's move to the seventh requirement. Okay, and don't worry, this is a warning. This is a warning, just a user warning. This is not a error, this is just a user warning. So chill, there is no issue in that. Okay, there is no issue in that. Right now we will train the model. Okay, because model training is also required, that's why I'm saying we will train the model. Okay, so let us go to the mail model training. Simple. They have told train the model for 15 epochs with batch size 32. Chill, easy. Let us go to the white board here. So model training is there. Train the model for 15 epochs with batch size of 32. Chill. Right now we will just write the command. After that we will understand each and everything. So I will write, and I hope we won't create any issue here, which we actually created by giving equal to. No worries for that. So here we will give x train. No worries, we will understand each and everything step by step. Okay, so y train y train, then we have epochs, epochs 15, because I am not good at spelling, that's why. And batch size 32. This much is required to train a model, that's it. Why we have done it, let's see step by step. So here we have used model.fit, all those stuffs. First let's understand what is dot fit. Dot fit, what it does and all. So dot fit, it trains the neural network on training data. So internally what happened, internally each epochs, like there are 15 epochs, right? So each epochs feed batches through network. It calculate the loss, it calculate gradients, and it update the weights. This happens thousand of times. Trust me, this happens thousand of times. And for that, what parameters do we need? We need x train and y train. Why x train and y train? Because training data and targets. Simple. Epochs equal to 15. Why 15? Because it will pass through the entire set 15 times, and also they have told 15. That's why. Let me show you here. Epochs 15, batch size 32. That's why also. What it actually does, that's what I have told. It will pass through the entire training set 15 times. And what we say, yeah, batch size equal to 32. Batch size equal to 32 means it will update weight after every 32 sample. I mean batching size, like if you have went for coaching or if you have learned for coaching kind of thing. In coaching they have batches, right? First batch, second batch, third batch, and each and every batch, or like take example of your school section or your college section. In college we have section, right? Like section A, section B, section C. Each and every section have kind of similar number of students in them, like 20 students, 20 students, maybe 21, like that. 20, 20, 21, 21, 21, 20, like that. Okay, so this is what batch size is all about. So batch size is equal to 32 means it will update the weights after every 32 sample. That's it. And why we are doing batching? Good question. We are doing batching because we want memory efficient output. I mean to say, it cannot fit all the memory in one place. That's why batching is required. Gradient averaging, because cleaner gradient is cleaner output, proper output, error less output, and better generalization, which is also called less overfitting. That's it. So that is the thing. So this is what all about the training of model. So model dot fit, and we have done this thing. Should I execute it? Obviously I should execute it. See, it is training the model right now. This is how models get trained. Epochs 15 times. That's what it is doing. Okay? That's what it is doing. It is like 15 times it's done and dusted. Easily you have seen how it is done and dusted. And it is what, like if someone asks you what 15 times, what it is all about, it passes through the entire training set 15 times. That's it, nothing else. Okay? So right now let's move to the next part of it. We will do the prediction part, because see, model training is done. Right now prediction part is required. Okay, this is the thing. So in this they have told for the prediction and evaluation, right? So prediction and evaluation, what it will do, it will generate prediction on test data and calculate the RMSE, which is root mean squared error, and MAE, which is like mean absolute error. This is what they will do, right? This is what they will do. They will generate prediction on test data and they will calculate the RMSE, root mean squared error, and MAE, mean absolute error. Okay? Let's copy and paste it in the whiteboard. This is the thing, right? Right now what we will do, we will do the prediction wala part. In this we will do, okay, oops, so predictions equal to model, we will predict, and in this we will predict what, we will do the X test. Then we will do again prediction. We will also take care of the scalar part. Scalar dot inverse transform predictions, right? Then we will have to write the y actual. Okay, and this y actual, what we will do, we will do scalar dot, I will make sure you understand each and everything, no worries for that. Inverse, I will make you understand each and everything. If I make you understand line by line, after each line you will just break the flow. I mean, your brain will actually break the flow. That's what I'm saying. I can make you understand line by line, but still the flow will get broke down and you will like, why these things are happening and all. Okay, so same inverse transform, and y test we will do -1, 1. Okay. Okay, now let's understand what it is all about. In prediction, what we have written here, we have written model dot predict and we have written X test. Simple. So in this, what it is we are doing, we are Okay, first thing first, what does dot predict do? What does predict does? Simple. What predict does? Okay, it passed the test data through trained model. That's it. It passed the data, test data, not any other data, test data through trained model. So for each test sample, it feed through all the layers and get a prediction matlab get a output. That's it. Right now we will see all those predicted things and accuracy at the end, no worries for that. After that we have what predictions equal to scalar dot inverse transform, and this prediction has been taken. What it is all about, it will convert the prediction back to the original scale. Like you can see, I have written prediction twice, so same prediction variable has been used to inverse that thing. Why we are doing this, why we are like converting prediction back to original scale? Because let me tell you one thing, what we have learned related to min and max volatility. We have learned min volatility was 0.1 and max was 0.8. So to reverse normalize, we have done it. That's it. Why we have done it? Because model train on 0 and 1 range, but we need answers in original volatility units for trading decisions. 0.5 means nothing. 4.5% volatility means something. So result will be like prediction will be in a shape, in a proper shape. That's what it is all about, right? It will give a proper percentage. That's what I have told you. Like 0.5, you will say no. 4.5, yeah, you can say yeah, there is a volatility in this stock. That's what it is all about. Now the third line is about y actual scalar inverse transform, and we are doing a y test reshape. So there are having, it is having two parts here. Okay. What it actually do, it converts the actual test value to the original scale. That's it. Why? Because we compare prediction in original shape to actual in original scale, which is the actual part, and both need some units. So there are two parts here. If you check out, first is y test dot reshape and then scalar dot inverse transform. So y test dot reshape minus 1 and 1, what it is all about? So minus 1 and 1 is all about infer this dimension, minus 1 is infer this dimension, and 1 is about column. That is the thing. That is the thing. And what is the meaning of scalar dot inverse transform? It reverses the normalization, like the same formula applied to actual values. That's it. So it's like, if you see, as I've told you earlier, the y actual, suppose it is like 0.01 and 0.08, and the range shape will be in 184 comma 1. So it is like that. Okay, simple. It is just reversing the normalization, like same formula is applied to actual values. That what it is all about, right? So prediction has been done. Let me just execute it. So again it will complete all the 15 epochs here. Again it will complete all the 15 epochs here. Done. Right. 60 for each time step. Okay, done and dusted. Right now let's move to the next requirement. Next requirement, they have asked for some output, like they want the inverse transform prediction back to original scale for interpretability. Okay, okay, let's copy and paste it. Copy here and not copy here, and paste it here. Okay. So here what it is, like what they've actually told, they are asking, okay, they are asking to inverse and transform prediction back to original scale for interpretability. Let us write the commands here. So actually what we will do, we will write some metrics here, to be honest. Oh sorry, I have not written this thing. So here what we will write, we will write okay. Okay, so a thing is, okay, what they are actually okay, so they want the output. So actually what output, okay, first thing first, if anybody is not understanding this thing, let me tell you what output actually they are asking for. They are actually asking for this two output, matlab root mean squared error and mean absolute error. They are actually asking for this output, okay, asking for this output, okay, that's the thing. So let me give it here rsme, simple. I will write rsm uh, rmse, sorry, rmse. I will write np dot square root np dot square root. I will write mean, then I will write squared error. I will explain you each and everything. Y actual, and we will write predictions, ठीक है. After that we will give something else, that is MAE, ठीक है, because they have asked for MAE as well. So MAE is what, mean absolute error, ठीक है. In mean absolute error, what it is all about, they need actual, y actual, and they need predictions, ठीक है. Okay, why I'm giving this to, I don't know. Predictions. Okay, let's understand this thing, what it is all about, this RMSE MAE, what it is all about. So RMSE is what, we are just calculating the root mean squared error, ठीक है, simple. Okay, let's see the maths wala part so that it will be easy for you to understand, right? What is actually the maths wala part here, ठीक है. It is like what I have actually done, square root of what I have actually done, mean, then I have written actual minus predicted, का square. This is what I have actually written here. So what it will do, it will calculate the error. Error is what, actual minus predicted. It will calculate the error, square each error. It will square each error, then take the mean of squared error and then take the square root. That's it, nothing else. But why squared error, why square error, you might be thinking. Not because like it is written root means square error, but there is a reason for it. Because see, penalizes large error heavily, ठीक है. That's what it is saying, मतलब whatever large error will be there, penalize it heavily. So example I am saying, if you have created one mistake, so it will be -1. Suppose in CAT exam, in IIT, in JEEs, like this, they have a negative marking. If -1 is there, it is okay, chalega. But if -1 plus -1 is there, then -2, -3, like this, it will create a lot of issue in the final output. So this is what we are doing here. We are just penalizing the large errors on a heavy state. Like one -1 error is worse than kind of -1, -1 and -1. I mean to say, one negative answer or one -1 is okay or better then -2 or -3. That's what I'm trying to say. That's it. ठीक है, that's what it is all about for RMSE. Right now we will go for MAE. MAE मतलब mean absolute error. So this also have a formula about it. Let me write it here. MAE. So MAE is what? It is all about mean of what? Actual minus predicted. ठीक है, it is about what? Mean of actual minus predicted, and here squaring is not required. We are not doing any square root kind of thing. We are not doing any squaring kind of what, so squaring is not required. ठीक है, so it is like actual minus predicted, mean is done. ठीक, so what MAE is doing, it is like treating all the errors equally. That's it. Earlier square root was there, here square is not there. That's it. That's the thing. So let us go to this and let's see if there is proper output or not. Let it okay, let it train again and again. No worries for that. No error about it till now. Don't worry about the warning part. Warning part is okay and good to go. ठीक है, so right now we will move to the next requirement. Okay, so it is the last requirement. We have to give some CSV files and all. Let us just copy and paste it. Just copy it here. We will read this thing, I mean the requirement here. No worries for it. Deliverables. So what we will do, we have to like save the train model, and model name we have to save it like that. We have to give the output in a CSV file. I will show you the output as well, like actual minus predicted, I mean actual versus predicted, and actual and predicted, what's the difference behind it. And in this we will see the console output displaying performance metrics. Okay, let's do it step by step. So it is just like normal work will be done, no worries for that. So okay, let's take results equal to pd dot data frame. What we will do, we will write actual. Okay, actual. Okay, not like this. So what we will give here, y actual. What we will do, we will do flatten. Okay, we will do flatten, and then we will take predicted. We will do predictions dot flatten. ठीक है, like this. ठीक, that's the result. Okay, so right now for that we have to take care of this as well. Results dot to CSV, and let us write the file name as results dot CSV, sorry, dot CSV, and in this we will write index equal to false. ठीक है, and her model also we have to save, right? Model also we have to save. Model dot save name. What was the name? Model dot h5. ठीक है, model dot h5 will be there. ठीक है, simple as it is. So let me explain this as well. No worries about it. So here what we have already done in this, we have created data frame from the directory, simple. And here we have two things. Okay, we have two keys here, actual and predicted. What they are, like two keys. Two keys मतलब simple language, two columns. ठीक है, two columns, and we have done the flat end, like it will convert 2D array into 1D array. So y actual का flattened shape will be in the output. So data frame always needs in 1D array. That's why as I've told in the previous part. So this is the thing, and this are what it is all about. The actual and predicted, it is all about two columns. Okay, that's it. This is the simple thing, results dot to csv, like save the results in csv file, simple as it is. And this is the name, results dot csv is the name. That's it. And right now index equal to false, index equal to false matlab it will not save any row number. ठीक है, that's it, that's it. ठीक. And anything, I mean to say index equal to for like the index number na in python, like 0 1 2 3, that won't be there. That's what I'm saying, simple language. And model, acha haan, one more thing, model dot save we have. So it is like it is saving the train model, like we have created a file for this, like 2 csv. So here what we are doing, it is saving a model. And what is h5? H5 is a file format. Simple. It is like a file format. That's it. Simple. That's it. Nothing else. Okay? That's the thing. And anything you need, anything else? No, na. So let us do one thing. Take it here. Paste it here. Why I'm saying this? Then again, it will train the model and all those stuff. Because I think we have no, I don't think we have anything else. So I don't think anything we have. Let's execute it. Okay, let's not take a risk. I thought we have anything else to find out, that's why. So we will just execute it again, and we will just take the I will show you the CSV file as well. No worries about it. ठीक है, I will show you the CSV file as well. ठीक, let me just do it. See here, result.csv is there. Now see, this is the thing, this is the actual one, 0.01269. This is the predicted one, 0.01235. ठीक है, 0.0120, 0.0121. This is the actual one and this is the predicted one. ठीक है, I hope you got it, right? I hope you have got it, what it is all about in a simple way, right? Do I need to find something else? Let me check the mail. Should we print the RMSE and all? Let us print it. Okay, let us print. Let us give an f string for RMSE. Let us give this. Let us print it, I would say. Right. 0.6f. So this is, oh sorry for this, MAE, and this also 0.6f. ठीक है, let us print this. So RMSE, what we have find out 0.001087 and 0.000819. ठीक है, this is the thing and we will save the file here. This is the additional thing, we are not doing anything extra here, that's it. This is the additional thing. Right now let's move to the mail and write a mail to them, reply mail I mean to say. Hi team, we have done the work for the requirement and also attaching the file for the same. Please have a look for the file. ठीक है, let me write the regards and let me just copy it here. Let me just paste it and we have to just take care of this as well. Should I directly paste it from here? Let me paste it directly from here. ठीक है, wait a minute. Okay, so we have done it already from here. ठीक है, we have already pasted this results.csv and right now let's send them the mail and let's wait for the next requirement. Let's send them the mail. ठीक है, mail sent results.csv, I am just crossing it and let's wait for the next requirement. Once we receive the next requirement, then again we will move to the Python environment and we will do the work. Till then let's wait for the next mail.